Thank you everyone for having me. Can you hear me well on the top? All right? Great. Thanks for having me. Thanks the organization for having me. It's my first time here at the Lambda Days, and I'm enjoying that a lot. And I'm Juliano. I'm going to talk to you a bit about refinement types and how that can make your life a bit nicer, a bit easier maybe. So first of all, who am I? So like I said, I'm Juliano. I am a Brazilian living in London for the last 4 years now. And I'm a software engineer, a searcher of perfect modularization, a lover of functional languages. I thought about considering like a big fan of Game of Thrones because I like titles, they sound great. And I consider myself, well, anyways, I work with like all these cool languages. I have experience with all the vintage ones as well. And this one is my Twitter. This one is my blog, where I'll be writing about this conference. I'm enjoying that very much. And I consider myself an open source developer as well. I spend some of my time contributing to the community as much as I can. I feel like I should contribute it back. I receive so much from the community. I try my best to give some back. And at the moment, I spend most of my time, my free time, working on Quill. What's a link for Scala? Who here already does know Quill? Who is using Quill? If you are not using Quill, give it a try. It will make your life super fun, where you don't have to write SQL anymore. Like you can use the compiler to generate SQL for you, what's super cool. And if you, as functional developers as you are, if you guys like to contribute to the project, it would be wonderful. We have 200 plus issues at the moment. It would be great to get some more help because it's a bit difficult to release and fix all of them. Like, people are very creative when they are trying to build weird queries. And at the moment, I'm building some software at TransferWise. We are hiring, so if you're interested, just send me a message, send me a tweet. If you want to work, or if you want to relocate, or if you live in London, Tallinn, Budapest, there are many offices, just come and have a word with me, all right? So I told you about what I am, who I am, but I didn't tell you what I'm not. And we are in the Lambda Days, and I'm not an academic, and I'm not an expert in categories theory, for instance, right? And don't get me wrong, like I really enjoy seeing all these people talking about it, and I really hope one day I'll get close from that level of knowledge. I'm not there yet, but that's the reason why I'm here. I want to improve. Because I'm interested in complex things, right? Since I was a kid, I always enjoyed Lego, for instance, right? I don't know, there's something beautiful in Lego in the sense of we have like small pieces, small building blocks. They are well defined. And when you put them together in the right way, they make sense, right? We can start with really, really simple things. And at some point, you have really complex things as well, but following the same principles. And that really attracted me, somehow complex things. And sometimes we reach the level where we have properly, unnecessarily complex things. But that's the same reason why eventually I became a software engineer and I started working on Quill, because I needed some more complexity in my life, of course, right? Things that I don't understand yet. And if we are talking about unnecessary complexity, let's talk about Java. When you start working with Java, and some of us started in this life, right? You have like common code like that, where you define your project, right? And doing so, you have commonly your factory to create a project. If you add Spring, it's very likely that you would have your project factory as well. What's always fun. And it's really, really, really easy to make a mistake when you do so, right? And during the talk about dependent types, the speaker, he asked at some point, if dependent types are so great, why are you not using that? And I think I have the answer. I actually have two answers, and they are both strongly related to strings, right? Strings, I think the answers are, people are way, way too busy using their minds to build solutions about strings. or they are trying to solve their problems that they created building those solutions around strings. And I found it wonderful how creative people can be. I mean, probably you've seen this, you've seen like this post that's from 8 years ago. And programmers have been using strings for so long in such a creative way that we actually have patterns about it. This post is for 8 years ago, and I still go to this post once in a while to see those patterns. And my favorite, that's easily one of my favorites, the stringly typed. Because people actually build systems around it. That's why we are not using dependent types. We have strings, right? Life is much easier when you're working with strings. Or maybe it's not. Oh. So yeah, we are thinking about complex problems we can build with well-defined structures. But when it comes to strings, it's more or less trying to build that with this sort of blocks where everything has exactly the same shape. What's not that useful? So after some time dealing with that, I learned about time types. And time types, they are pretty much a first attempt to use the compiler in our favor. So we can, at this point, build a name and a description for our project that they have the string inside, and we don't have to deal with that ourselves. And in that case, when we use your project factory, at this point, well, the compiler tells us, that's cool, that's not working. So our life is slightly easier at this point. I mean, the compiler is helping us. That's why the compiler is there. We should use it in our favor. However, of course. It's an interesting idea. Of course, it didn't come from the Java community. It started in Haskell. Haskell has this definition for what I call time types. I'm sorry, I'm not a Haskell developer. I don't know how this is called in Haskell. Is that called time types as well? No? Let's call it time types, so, all right? In that case, from this moment on, I baptized that type as time types. Not just Haskell, actually, from the ML family languages. Haskell adopted that one as well. And then, well, if we try to reflect that, not back in Java, it's enough, right? Let's say we reflect that in Scala, and we will have the case classes to define those time types. We would have the name, description, and our project that has a name and a description. At this point, coming from a Java background, something here for me was already valuable because I could consider the expressiveness of this code, what is strongly related to that maintainability. A code that's easier to read, it's easier to maintain, obviously. So having that and having this definition right here, we start to think about what else can I use in my favor. So I decided to go a bit further and define some validations for that code. It's not just having this time type, not just about being more expressive, but now my domain is a bit more well-defined. So why not have that name giving me the information about what's correct, what's not, giving that small context, that small universe of a name. So let's say that a name has to have at least 10, size 10, and a description cannot be empty, for instance, right? Just a slightly different one. And my next steps were in that direction. Let's solve it. So doing so, I decide to try to create this new name, right? And a new description, Mandalorian, that's better than the movies. It's good that everyone agrees, apparently. No one complained. And the next step would be to build a project. But to do so, at this point, you can see here that to be valid, I would have to use an option. So to build a project, I would have to do something like that. So it's interesting how that starts to proliferate around my code. Because to have a project now, I would have to have an option of a project. If I want to compose that with something else, I would have to have an option of an option, and so on and so forth. And at this point, I started looking for other options, but everything I could find would just make it more and more complex, because I can try to do such a project with cats in that sense, or another possibility with cats as well. But that's not that expressive anymore. There's a lot of noise in this code. That's not what I wanted. I wanted to stay with the simplicity of the code, right? Does it solve my problem? Ish. It's a Java-ish solution. The options are proliferating, and I have too much validation code, right? And then it's when we finally get to the title of this talk, to the refinement types, right? Looking for a better solution, that's what I eventually found. And a refinement type is a type endowed with the predicate which is assumed to hold for any element of the refined type. Refinement types are thus related to behavior subtyping, according to Wikipedia. What sounds great, but when I read that, I was like, okay, so what, right? In summary, a refinement type is just a base type plus a predicate. And that's it. It's that simple. So when you look back to the code, and then again, obviously, we have a solution in Scala, already built. Recommend it. Go for it. You can solve the problems of your life. Using refined, we can finish like having a code like that. And the next step, that will take us to a place like that. Using a few constructions that refined provide us in that library, I can define some collections, I can define some strings, I can define some rules for a given base type, and then a given predicate. That's what that Wikipedia description means, actually, right? So from that point on, when I'm building my project, I have something like that, where, again, we have those definitions right there. The string plus a predicate that tells you how that's valid, what's the precondition to make sure that the type is valid. And then when you try to build a project, you can have a valid project that will give you project as expected, and an invalid one, with these indications that the predicate OI failed because of that specific reason. What's cool, I mean, it's a reasonable message, but the best part, it happens in compile time. We are not suffering and figuring that on the fly. So we don't have to validate that in exactly the same way. It's already intrinsically part of that type, correct? So this next step would be, okay, but how does the Scala compiler build such a construction for us, right? And anyone that works with Scala knows what's the answer. Macros, right? Macros are the solution for almost everything in the Scala world because it allows us to manipulate most of our code. However, as you saw in the outside, that's a beginner's talk, right? So I was trying to come up with a way to explain what Scala macros actually are. And better than a proper explanation, I managed to find an image that gives you a proper understanding of what they are. And they are something more or less like that, right? In the world of Scala macros, time and space doesn't exactly make sense. But it doesn't have to make sense, right? We don't need to understand deeply the fundamentals of that just to use a tool that gives us more expressiveness. I like to call it the dark playground, by the way. The ones that enjoy Scala and want to contribute to Quill, there's a lot of dark playground for you to play around, so you are all invited to enjoy the party. When we go back to to our project. So at this point, yeah, we have that. As mentioned before, we have the definition, type description, and a class project. and then we have a smaller project. What are the advantages of using Refined at this point? We have a domain reduction, right? Our domain is a lot more concise. It's a lot more clear because less code, I mean, no code is better than any code, but less code is better than more code, meaning that's way easier to reason about it. That's something that attracts me as well, is making the compiler work for us. That's the initial, that's exactly what attracted me to contribute to Quill, right? You extract information, you make the compiler work. What can be a bit tricky, but I like to write less. So if I can have the compiler writing more for me, somehow that's exactly what happens. And the most important one, it's way easier to test. And most of our tests will become irrelevant. I mean, there's no point. If your code is incorrect, at this point, it just doesn't work. It just doesn't compile. In that case, we don't have to test it, right? Obviously. Being, for instance, having a name that has to be a minimum size of 10 becomes an intrinsic part of that construction. There's no point in testing that. There's no, I mean, you can, but you just see your code not, no, there's no point in doing so. That's that simple. Refined provide us with many predicates, actually. I don't think I should just walk you through every single one of them because it's a relatively simple lib to use in the sense of you just refine any type that has to be, that has to, let's say, obey some specific validation. So something that should be true or false, that's not a good one. Okay, but if a char has to be a letter or not, if the collection contains something, or all the elements in the collection have to satisfy something, it's pretty much everything. For the ones that actually work with Java, probably you'll remember that Guava preconditions, right? That was pretty much a way to validate all these small bits when you are building your objects. But suddenly, you can make it part of your object, and you don't have to validate that anymore. You can, because you cannot construct that if it's not valid information, right? So I invite all of you to have a look. It's very well documented, and it's very simple to use. So it's better if you just have a look to refine it. And how can we use them? Well, we can combine them, what can be very useful for us. So thinking about that's a slightly more complex construction. When you say that I have to follow some specific fundament validations to build a GitHub handle, I don't remember where I found it, but it says that it should have a username, just alphanumeric. If it's just alphanumeric, cannot have more than one hyphen. It cannot start or begin or finish with an hyphen, and minimum 39. So obviously, non-empty here. Oh, sorry. Okay. Yeah. So we have the non-empty one, followed by this for all ladder of digits, and then I'm saying, okay, you can actually have the hyphen, no two hyphens. That's probably not the best way to build it, but I think it was good enough for a simple example, right? It works. Now kind of feel like I have to prove it works. So okay, I'll take the risk. Okay. So just to have a general idea of if it's actually working, let's say that I have my type name. Okay, that's going to be, okay. So if I say that I have a name, it breaks, right? Ah, good, awesome. And then if I say, if it satisfies the predicate, it works. Great. So going to our a bit more interesting construction. I think I have it here. I think that's an invalid one, right? I mean, it's kind of start to hurt looking up. So. Okay, so that one should break because it's way too big. We needed to, let's say, oh. So if we have one that starts with a hyphen, it doesn't work as well. If it finishes with a hyphen, it doesn't work as well. If it's, I have both here. It has to break as well. 2 hyphens, right? Fails, hopefully, thank you. And then if we don't have, oh, it works, hopefully. Yes, it does. Okay, so far so good. However, I can see many people looking at me more or less with this face at the moment, because that can be really helpful when you are building any sort of software that doesn't rely on random inputs, right? I mean, if you're talking about an HTTP application, you get like random inputs on the fly. And in that case, it's not that useful, right? Because I cannot use Refine in that sense. So how can I actually use that in the real world? So there's an interesting, here, back here. Oh, no. Oh. So we have an interesting construction here. That's the refined type ops. And when you use a refined type ops, we can just create the companion object for that object for that type we defined it before. And from this moment on, our GitHub, yeah, I should have stayed there. The GitHub handle from that point on has a method from, where I can call it with whatever. And then I have an either from this point on. And the validations are still in place, which means that from this point on, we can actually compose that. Either is possibly not like the best way to compose these sort of things. However, it's composable, right? From this point on, you can lift that, you can transform that the way you like. Or even for simple things, you can just match and see if it's a valid information, if it's a valid input or not. That makes it useful in the real world, at least in the first moment. Oh, yeah, that's the same example, right? There are a few drawbacks when it comes to use Refinement, though. The first one is compile time. Probably you noticed when I was running it, even being my console, it was like relatively slow. I mean, you can actually see that. And if you keep adding more and more refined types, you should be aware of, should take good care of your compilation time. Don't exaggerate in the sense of, I would say it's similar to the way that people used to use implicits just because, right? It can add to the compilation time. So don't misuse that. Be aware of that. It's a possibility. Well, at the same time, if you don't do that, you have to write more tests. So you are saving time in your place and taking from the other. That's how I like to think. But then again, I still expect the compiler to do the work for me. The validation error messages, they could be better, right? This one on top, it's not exactly the most readable thing, right? I mean, we have an extra hyphen, and you have to kind of search around. It aggregates the messages all together. It's not the best. Still, it could be improved. So, in summary, why should we use Refined? Well, because it's type safety, and that's why we are all here, right? Like make our lives a bit more type safer. The validations, then again, it's arguable if it's the best approach, but if you have either, at least it becomes uniform as long as you're using Refined. It has some benefits of doing so. It's a lot more expressive, and what improves maintainability, and it's easier to test because you can delete tests. So less tests are breaking, right? That's a good approach. I hope, my approach at least. Hope I could pass to you the idea of why I use Refined, why you could start learning from that. It's a simple library that can do a lot for you. Thank you very much.
Any questions?
Hello, hi. With your demo with the GitHub handles, you could see there was quite a lot going on in terms of the different character checks. And I was wondering, are the rules Turing complete? So for example, could you have refinement type for is a prime number, for example? Is that something you can do, or are you limited in the kind of calculations you can express?
In theory, you could, but to be entirely honest, when you try to make a complex composition to build, like I said, those specific characters, this sort of things, I'm using shapeless to do so. I noticed that when you start using a lot of them, it starts to get like slower, but not just, it can become like really slow when you do such a complex validation, like you said, if it is actually a prime number. I don't remember which one I was trying to do the other day, but it was something that would keep growing the same idea. And if I try that with like a low number like 2, that would be all right. With 800, it would take like a lot more. And therefore, I don't think that's the best approach to abstract such a complex validation to types in that sense. At least my knowledge dealing with this lib, I wouldn't advise to do so.
Thank you.
There's another question over there.
As you told, it is based on macros. What is the future of this with Dotty?
Sorry, can you repeat it, please?
What is the future of this stuff with Dotty coming? That will throw away the actual macros and allow new kind of macros and so on.
Sorry, I didn't understand.
The next generation of Scala will throw away the current generation of macros. That, as you told, power this somewhere inside. Is this some kind of plan to address this, or this will die when Dotty comes, or something like this?
So apparently coming iterations of Scala will throw macros away.
Sorry, I can't hear you now.
You can't hear me?
No, I can. No, I can. But yeah.
Did you understand the question?
Yeah, no, I didn't get what's the question. Sorry.
Yeah. So he was explaining that future iterations of Scala will throw macros away. I think. Is that right?
The current macros and new kind of macros that are completely different.
Oh, okay. So is there a future for this, for the refinement library, given that future releases of Scala? Because they're going to get rid of some of the language features, apparently.
I have to apologize, I can't understand.
Let me try one more time.
So this one I get it, like, I really didn't.
If they are asking whether the macros will get torn apart in Scala 3, the answer is no.
Ah, right.
What they know.
Oh, yeah. Oh.
Martin he said that macro support was kept in place.
Yeah. Yeah, sorry, I really didn't understand. I'm sorry. More questions?
Thank you for your presentation. And my question is, if I have two types, let's say one string that's minimum length of 10, and the other one which is minimum length of 15, then can I use the latter when the former is expected? In other words, is string of minimum length 15 subtype of string of minimum length of 10?
Like using a refined with another refined.
Yeah.
They tend to be composable, but commonly thinking about the expressiveness of every single one of them, I don't, for instance, I could say something like I have a string minimum 5, right? Something like that, and then use it again. But personally, I'd rather go and just use the refined for a string in that specific size. But in theory, you could just, it's a simple thing, but to be honest,
But that, can I pass?
Break.
Can I pass?
Actually, that's easy to figure, isn't it?
Okay.
So you're saying if we have, let's see, let's see if I have a copy of something here. So I'll write it here first just because it's easier for me, right? So type min 5 string refined. So you are asking if something like and then if I say something like type min 5, I don't know, max 10. Oops. Min 5 refined. Something like that, right? That's the question. If something like that would work. Okay, it's becoming a party session now, so. Oh, that's not the one? Oh. Well, we still have like 5 times. Okay, but for the record, I'm pretty sure that's gonna break. I'm pretty sure that's not gonna work.
Maybe we could take another question.
Yeah, okay. Thank you very much for your time.
Okay.